Share screen. First of all, what's totally fascinating is I have this band up there that I can see where people are on which Jamboard. And it's fascinating to see you guys just move from like one Jamboard to the other during the whole group work, which was totally awesome. And I love that when confronted with a problem, you guys decide to make like one big, happy breakout room where you were like all participating on the same Jamboard. That was really awesome. So thank you for doing that. What did you guys come up with? What ideas came up from, so this is gallery walk, right? So this is group one. Make a video, explain how it turns, draw a current arrow, show the circuit, explain the parts, start out explaining the circuit, putting the, show both the negative and the positive. Did you mean changes or did you mean charges?
Um, I was I was gonna say like uh show the negative wire on the south side and then the positive wire.
Okay, cool. So the positive, it's not even the positive, yeah, the positive end and the negative end of the wire, right? We agree on like on that vocabulary. Um, and then I'm curious about this picture here. I'm assuming that's a compass.
Yeah,
And
I did that.
the arrows represent a current.
Yeah, I was just thinking because like I might like draw it because I feel like that might be a little bit easier to explain.
Yeah, so I would just be very careful that just in terms of your picture, right? I would be very careful to show
Oh
that
yeah.
you want the current to actually enter through the, yeah, that's better, right? That makes me feel warmer and fuzzier inside, as
All
much as
right.
possible for a French person to be warm and fuzzy. But cool. Group two. Um, so your idea was to use two batteries instead of one. The deflection will be stronger and easier to see. Makes total sense, but the same circuit as before. So do you mean like the two batteries, one light bulb, two wires kind of thing? Is that?
Yeah, yeah, the same one as we did, but just with an extra battery, just to show the deflection more.
Totally, it makes complete sense. Use purpose circuit, show explain changes, show circuit and diagram for the circuit. Okay, so not only make sure that you show the circuit itself, but show a diagram. That's a new piece of information, right? It sounds like you're all collectively agreeing that you should use the same circuit. Film the video with the same circuit as before. Make sure you can clearly see all the parts of the circuit. Explain what you're doing with the viewer. So yeah, make sure like you understand like that explanation, like what it is that you're doing, how what you're connecting to what. I would walk like the same way that I did on my circuit here. Like when you, this is my negative end of my circuit, and I'm just walking through my wire, right, all the way to the bat, all the way to the, all the way to the compass. Pinpoint where the negative charges and positive charges are. So again, we just need to be a little bit, I mean, we just starting this, so we have the vocabulary we have, it's not a big deal, but we need to be a little bit careful. There are negative and positive charges around us, right? Those are called protons and electrons. Only the negative ones are moving, right? The protons make up the bulk of stuff. Like, so if you think about like your wire, right? This wire is made of positive and negative charges. The positive charges actually literally make up the wire. Like that is what the wire is made of. It's made of the positive charges. The negative charges flow along the wire. So the negative charges are the ones that are moving. The positive charges stay put, right? Like the positive charges don't move. They just stay put. And you want to start explaining the circuitry and how to flip the wire, make sure to pay special attention to the orientation of the circuit, not to get that messed up. Yeah, that's going to be really critical, right? Remember, you want the negative end of your wire to, you want the negative charges to reach the negative end and enter, they don't enter, but like enter through the southern end of your compass and exit through the northern end of your compass. And that should create a positive deflection. That should create a clockwise deflection. Cool. Any last questions before you guys go and do your thing? No? Okay. You guys are amazing. Thank you for a good class. I will see you on Tuesday.
Thank you.
Thank you, Nicola.
Thank you.
Thank you.
Bye.
Oh, I had another quick question.
Yeah, go ahead.
So don't positive and negative charges like repel from each other?
So positive and negative charges attract, actually. Like charges repel, opposite charges attract. Mm-hmm.
Okay. So does that have anything to do with like how the compass deflects?
It's complicated. The compass, I mean, obviously it does, right? Because if you change the direction of the current, you change the deflection of the compass. So obviously they're linked. Like how the electrons flow, the direction in which the electrons flow, totally determines the clockwise versus counterclockwise deflection of your compass, right? Absolutely. The relationship between the pluses and the minuses and the deflection, that's complicated. Like that's just like that's second level.
Okay.
So physics 2, hold on to that question, write it somewhere, and when you take physics 2 at the base school, then you can go and ask Julie that question, and she'll be super excited.
Thank you, Nicola.
Bye.